That's what a drone kill really looks like. Not a missile screaming in from far away, just something small and far off that nobody bothered to react to until it was too late. That soldier didn't die because the drone was fast, or hard to see, or expensive. He died because for most of the flight, it just didn't look dangerous. That gap, between looking harmless and being deadly, is the whole problem with this weapon. And that's what this video is about. In this video, we're going to break down how FPV drones actually work in combat, how the pilot flies it, how it finds the one weak point on a heavily armored target, why it takes weeks to train a pilot instead of years, and why the economics of this weapon are quietly rewriting what an army even needs to win. Start with the pilot, because the drone itself is almost secondary to the person flying it. FPV stands for first-person view. The pilot wears goggles wired directly to a camera on the drone's nose. So what they see isn't a screen from a distance, it's the world rushing past exactly as the drone experiences it. It's not a missile fired from a distance and forgotten. It's a machine flown, in real time, by someone watching through its own eyes. There's no autopilot doing the hard part. Every dip under a tree line, every last-second correction around incoming fire is a human hand on a small controller, reacting in real time. That's what makes the drone so hard to stop. A machine flying a fixed pattern is predictable. A person improvising at speed is not. The signal linking pilot to drone travels on radio, usually over an analog video feed for the lowest possible delay. Because even a fraction of a second of lag at high speed is the difference between threading a gap in a tree line and slamming into a branch. And that speed is real. A combat FPV typically closes on a target at somewhere between 45 and 95 miles an hour. Fast enough that by the time a target's crew reacts to the sound, the drone is already most of the way there. Range depends entirely on what the drone is built to trade away. A basic FPV on a stock battery might only reach about 12 miles before it has to turn back. Push for lighter construction and a denser battery, and that number climbs toward 45. The current extreme sits above 60 miles, but that distance comes at a cost. A drone built to fly that far is usually carrying a much smaller warhead, because every gram spent on battery is a gram not spent on explosive. That trade-off, range against payload, defines almost every decision in how these things get built. Most pilots never actually fly close to the drone's maximum range. A relay antenna mounted on a mast, or a second drone hovering higher up, can extend the usable control range far past what a handheld controller alone could ever reach on its own. Now get to the part that actually kills the tank, the warhead. Most FPV strike drones carry a shaped charge, the same basic principle behind an anti-tank rocket. A cone of metal, usually copper, sits in front of the explosive. When it detonates, that cone doesn't just blow outward, it collapses inward into a thin jet of molten metal moving at several miles a second. That jet is what punches through armor, not the explosion itself. It's a needle of superheated metal driven by chemistry, not a fireball. A charge built on this principle can punch through roughly 12 inches of steel-equivalent armor. The heaviest tandem versions, a smaller lead charge that clears reactive armor, followed by the main charge a fraction of a second later, push past 16. But raw penetration isn't really the point. A skilled pilot doesn't aim at the thickest part of the tank. They aim at the parts the tank's designers didn't bother armoring as heavily. The roof is the classic target. Engineers load the front and sides of a tank with the thickest steel they can afford, because that's where they expect an enemy tank or anti-tank round to come from. The roof was never supposed to matter. Nothing used to attack from directly above. Now something does, every day, and it dives straight down onto the one surface the tank was never built to survive. Beyond the roof, pilots go for the seam where turret meets hull, the driver's optics, or the exhaust grill venting straight into the engine bay, or exposed reactive armor blocks, strong against a shell but useless against a warhead detonating from an angle they weren't designed for. Hit the ammunition rack through any of these points, and the tank doesn't just die, it cooks off from the inside and the turret goes airborne. None of this happens on the first attempt for most pilots. Threading a moving 4-inch target through wind, dust, and the last-second jink of a driver who spotted the drone takes hundreds of practice runs before it starts looking effortless on camera. This is where the economics become impossible to ignore. Analysts now put the average cost of an FPV confirmed kill at somewhere around $1,300, once you account for the drones that miss, get shot down, or get jammed before they arrive. $1,300, against a machine worth thousands of times that. And that ratio is the entire reason this weapon scaled the way it did. Ukraine alone is now producing somewhere north of 50,000 FPV drones a month, not because each one is guaranteed to hit, but because at this price you don't need every one to. Most of that production isn't happening in a factory with a guarded perimeter. It's happening in garages, back rooms, and small assembly lines that can be set up and torn down faster than any facility building actual armored vehicles ever could. Which brings up the other half of what makes FPV drones so dangerous: how fast a pilot can actually be made. Training a tank crew takes months of schooling before anyone touches a real vehicle. Training a fighter pilot takes years. Training a competent FPV operator takes something closer to a week of structured practice, sometimes less. Building on hours spent in a flight simulator before ever touching a live drone. That's not a minor detail. It means the bottleneck in this kind of warfare was never really the pilots. It was always the drones themselves, and drones are the one part of this equation that's cheap and fast to build in bulk. Most new pilots start on a simulator, not a real airframe, crashing a virtual drone hundreds of times without ever putting a real one at risk. By the time they touch an actual controller connected to actual goggles, the muscle memory for basic flight is already there. So step back and look at what's actually happening here, because it's bigger than one weapon. For most of military history, the side that could afford the most expensive weapons had the advantage. Better armor, better guns, better planes. FPV drones flip that logic. When the exchange rate is $1,300 to destroy something worth millions, the expensive side isn't the one with the edge anymore. It's the side that has to spend the most money defending against a threat that costs almost nothing to send at them. This is what economists studying conflict call an asymmetric cost exchange. It's not new to warfare, but it's rarely been this extreme. A rifle-armed insurgent forcing an army to spend millions guarding convoys is the same math on a smaller scale. FPV drones just took that principle and applied it to the single most expensive weapon system on the modern battlefield, the main battle tank. A single interceptor missile built to shoot down a threat like this can cost more than every FPV drone that side will build in a month. Fire enough of those missiles at $1,300 targets, and the defender goes broke long before the attacker runs out of drones to send. An army built around expensive, heavily armored vehicles was designed to win a war of quality. FPV drones force it to fight a war of quantity instead. The defender has to intercept, jam, or armor against every single cheap threat, while the attacker only has to get lucky once in a while for the math to work in their favor. This is why you now see improvised cage armor welded onto vehicles that never needed it before, and crews sleeping under nets meant to catch a drone before it ever reaches the hull. None of it is elegant. All of it is a direct, panicked response to a threat that simply didn't exist a decade ago. That's the real story underneath the footage of tanks getting picked apart one at a time. It was never really about one drone versus one tank. It's about which side can afford to keep losing $1,300 at a time, and which side can't afford to keep losing millions. And that math doesn't stay confined to a battlefield forever. Every military planning department on Earth just watched an army with almost no air force ground down one of the world's largest tank fleets using hobbyist parts and a week of training. Whatever doctrine gets written next, it's being written with that lesson in the room.